All right, so let's suppose you want to graph this quadratic function, f of x, equals 2 times x, and I think that's a plus 3, x plus 3 squared minus 7. Why is this? All right, so f of x equal 2 times x plus 3 squared minus 7. Okay, so what is it that you need to, what is it you notice about this function? What is it written as? Vertex form. So you have to recognize that this is vertex form. Now, since it's in vertex form, you can find the vertex. What's a vertex? -3, -7. -3, -7. So this is in vertex form. All right. All right, so then we can find the y-intercept, right? So how do you find the y-intercept? You're going to let x equal 0. And so when I let x equal 0, okay, so when I substitute 0 for x, I get f of 0 is 2 times 0 plus 3 squared minus 7, correct? And then what's 0 plus 3 squared? 9 times 2? 18 minus 7? 11? So my y-intercept, if I don't tell you to write as an ordered pair, then you can just say 11, or as an ordered pair it would be 0, 11. All right, then does this quadratic function have any x-intercepts? How can you tell? Come on, guys, we spent 3 days on this so far. Well, this is the 3rd day. How can you determine if this has?
Because 2 is positive, which is A. A is positive.
All right, so you need to know where the vertex is located. Where's the vertex located?
Quadrant 3.
In quadrant 3. Basically, all you really need to know was that it was below the x-axis, right? And does the parabola open up or down? How do you know it opens up? Because A is positive. A is a positive 2. So it does this. So you are going to have x-intercepts. All right, so we got to find them. So how do you find the x-intercepts?
Substitute Y for 0.
So you let y equals 0. And so remember f of x is 0. So this function right here, I'm going to set equal to 0. All right. Now, you had something like this on a previous test. So you see that binomial squared? On a previous test, to get that, to solve for that variable x, what property did you use? The square root property. But in order to use the square root property, you have to get this part by itself. So what do I need to do first? Add 7 to both sides. So I get 2 times x plus 3 squared equals 7. What's the next step? And so I get x plus 3 squared equals 7 halves or 3.5. Since it terminates, I can write as a decimal. All right, then what's the next step? Take the square root of both sides. Well, remember when you do that, you get that plus or minus. So when you take the even root of both sides of an equation, Don't forget that one side, you have to have that plus or minus. So the squared and the squared don't do each other. So what do you have left?
X plus 3 plus or minus square root of 3.5.
Equals plus or minus square root of 3.5. Now remember what that means is this. X plus 3 is going to equal two things. What's one of them?
Plus 3 point, I mean, square root of 3.5.
Square root of 3.5. And then what's the other?
Minus 3 negative.
Minus square root of 3.5. All right, so then use your calculator. So first of all, how do I get x by itself? Subtract 3. And so my x-intercept is negative 3 plus the square root of 3.5, and the other is negative 3 minus the square root of 3.5. All right, so round that to the nearest 10th. So you round to the nearest 10th. Make sure you know how to use your calculator. So you're going to say negative 3.5, I'm sorry, negative 3 rather, plus the square root of 3.5 equal negative 1.1 for this one. And over here, negative 3 minus the square root of 3.5 equal negative 4.9. Okay, so those are your two x-intercepts. And in terms of graphing, and on my math lab, that's basically what they're going to ask you to do is to find the intercepts, find the vertex, and then graph. Now, they're in some of them, not all of them, in some of them they're going to ask you to find the domain and range. So we're going to do that as well. Okay, so I'm going to go ahead and use this graph paper because I think we'll be fine with 11. So my vertex is negative 3, negative 7, correct? So that's here. Even though I didn't mention it, I want you to draw the axis of symmetry so you can draw a better graph. Now remember, is the axis of symmetry part of the graph? No, you just use it. You just use it to help you to draw a parabola that looks symmetrical with all this information that's there. All right, so then you know that the y-intercept is 11. Okay, did I do something wrong? Oh, the y-intercept is 11. I was about to do down here. It's way up here, right? All right, so right here, there's a y-intercept. Okay, so if I notice I extended the axis of symmetry. If I know that this is a point of the graph, then I also know another point that's on the graph. So this is 3 units to the right, so then you're going to go 3 units to the left. So this point here, negative 611, is also on the graph. All right, and then the other number, usually I'm going to ask you to plot about 5 points. So here's 1, the vertex, here's 2, and then the other 2, if there aren't any x-intercepts, the other 2, well, you're just going to plot a point. But there are x-intercepts here. We found them to be negative 4.9, so close to 5, about right here. And the other one is negative 1.1, which is about here. Make sure you're on the right side of negative 1 now. And notice that these distances right here should be the same, right? Those distances should be the same. All right, and then do the best you can. And notice how I'm doing this. I'm kind of doing this in, remember the little, back in the day, what's it called, sketch? The little red thing, and you could etch a sketch?
That was my first laptop.
Huh?
That was my first laptop. Mine too.
Yeah, I think it was most of ours. All right, so think of that etch a sketch right here.
We have someone who said, "What's an etch-a-sketch in here?"
Oh, Google it. Google it. All right, so it's kind of like I'm doing that etch a sketch. See all those? You remember those little magnetic,
Reality was
like little pieces of hair? It wasn't hair, but like magnetic lead. So you see how I'm doing this? Do the best you can with this. Kind of do the same thing. Think etch a sketch. That was your first laptop?
Yeah, ViewMaster was my first virtual reality goggles.
All right. So there's the graph. Okay? That's what it looks like. All right. So any questions on the graph? All right. Now, even before you graphed this, you could have told me some other information. I could have asked you, without looking at the graph, I could have asked you, what's the domain? You would have said what? Right, because this is first of all, is this a polynomial function? Yes. It's a polynomial function. All polynomial functions, the domain's all real numbers. Now remember, we talked about a polynomial function. So a polynomial function has this form. So it's some coefficient, I'm going to call it A1, times x raised to a power. I'm going to call that N1. And that exponent has to be a whole number. So 1, 2, 3, 4, 5. It cannot be negative. So notice I didn't say integer. I said a whole number. It could be 0. But not a decimal. It has to be a whole number. So notice that when we talk about quadratic functions, all those exponents are whole numbers. Plus some other coefficient times x to another exponent, and so on. And the last term, we normally write, what is the last term? What is that called? The C, your constant? Okay. All right, and so notice that this, if you were to FOIL this out, it would be quadratic. It would fall into this polynomial function. So all polynomial functions have domain that's all real numbers. Even before you knew what the graph was, or what the graph looked like, you could have told me the range. In fact, in my math lab, on one of the worksheets, it's going to say, without graphing, what's the domain, what's the range? So to find the range, you need to first of all know what the vertex is. What's the vertex? -3, -7. And in your mind, you have this rough sketch of it right here. So my vertex is -3, -7. And you know it went up, right? It opened up. We talked about that. So your range, you go from bottom up along the y-axis. So I start touching the graph at what y value? So -7 all the way to infinity. Okay? One of the things that you were asked to do yesterday was determine where the function is increasing or decreasing. So f of x is increasing blank. F of x is decreasing in what interval? All right, so remember, when you talk about increasing, decreasing, you're talking about the domain. What values of x is my y value? Remember, f of x means what letter? Y. So where's y increasing? For what values of x is y increasing? So without sketching a graph, without doing this, you could have looked at a rough sketch of it, and this is my axis of symmetry. So from -infinity to this x value right here, what's that x value right here? -3, right here, -3. So from -infinity to -3, what are my y values doing? They're decreasing. So -infinity to -3. And remember, when we talk about increasing, decreasing, those are open intervals. And then from 3, when x is 3 all the way to infinity, what are these y values doing? So negative 3. So from negative 3 to infinity, what are these y values doing? Increasing. Okay. What else did we talk about in terms of information you could find for a quadratic? We did x-intercepts, y-intercept, domain, range, increasing, decreasing, max. What's the maximum? Oh, is this a maximum or minimum? It's a minimum. All right, now be a little bit careful because one of the worksheets yesterday asked this. So we get a minimum point, right? And where's that minimum point? What's the minimum point?
0, -7.
What is the minimum point, David? -7. Okay, so the minimum point is -3, -7. What is the minimum value? -7. So if it says value, that's the y value. So you only put the y value there. Okay. All right, so that takes care of that one. All right, now let's look at this one. Okay, so suppose that this time you're told that g of x equals negative x squared minus x minus 7. So negative x squared minus x minus 7.
Minus 8x?
Yeah. What did I say?
X.
Negative x squared minus 8x minus 7. What form is this? Diurnal form. So what are you going to use to determine the vertex?
That formula.
The vertex formula. And remember, the vertex is a point, an x coordinate, a y coordinate. All right, remember that hk? So h is your x coordinate. All right, so remember to find the vertex, your x coordinate, and it's easy to remember because it's part of that quadratic formula, negative b over what? 2a. So that's your x coordinate. To find the y coordinate, you take that x and plug it back into your function g. So that's g of, in this case, g of negative b over 2a. All right? So that's your vertex formula. All right, now be careful because, listen to this, it could have been written like this. On my math lab, there's one written like this. So be careful. If it's written like this, what is a? -1. Remember, a is still the coefficient of x squared. So you may want to rewrite in descending order. So don't forget, you got to, when you see the one that's written like this, make sure you write it like this. So what's a? What's b? And what's c? All right. So the x, I'm finding the vertex. So the x coordinate of the vertex says the opposite of b. What's the opposite of b? 8 divided by 2 times a, what's a?
-1.
So I get 8 divided by -2, which is a -4. So far, my vertex has x coordinate -4. How do you find the y coordinate?
Substitute -4 into x.
So basically, to find the y coordinate, you're finding g of -4, correct? So in place of the variable x, you're going to substitute -4. So I get negative x squared. What's x in this case? Put that in parentheses, like this. Negative x squared. Negative x squared. Minus 8 times x, what's x? And minus 7. All right, order of operations, what's -4 times itself? 16 times, the opposite 16? -16. A -8 times a -4?
132.
And then minus 7. -16 plus 32? 16. 16 minus 7 is 9. So my vertex is -4, 9. Now remember, what's the domain?
Negative infinity to infinity.
Because it's a polynomial function. So in the domain is the x value of 0.
Yes.
So letting x be 0 can help you to find the y-intercept. Now, in general form, it's a lot easier to determine what the y-intercept is versus the vertex form. General form, if it's in general form, right away, what is that y-intercept? Huh? It's your constant. What's my constant here? -7. It's c. c is your y-intercept, because it makes sense, because when I let x be 0, here we gotta let x be 0. When I let x be 0, this term's 0, -8 times 0 is 0. The only thing that's left is c. So -7. So my y-intercept is -7. All right, do I have any x-intercepts? Am I always going to have an x-intercept? No. How can it tell if this function g has an x-intercept?
Look at your vertex and then look at A.
All right, so the vertex is located where? So kind of draw something like this, so you know it's -4, 9, so it's in the second quadrant, right? What is A? -1. So A is negative. So that means that my parabola is open downward. So am I going to have x-intercepts? Yes. So we can find it. So to find the x-intercept, you let y equals 0. What means the same thing as y over here? What means the same thing as y over here? G of x. So I'm going to take this function right here and set it equal to 0. All right. So notice what I have. What kind of equation is this? Quadratic. That's a quadratic equation. Not all of them, remember, not all quadratic equations are factorable. Remember the second test? You were given like 2 quadratic equations. One of them you were said solve by factoring. And the other one says solve by what? Quadratic formula, because that one could not be factored. You had to solve by using the quadratic formula. Okay? So if that negative out in front throws you off in terms of factoring, then what can you do? Quadratic formula. So you may, if you're not sure if this is factorable or not, and they're not all factorable, then go ahead and solve by using the quadratic formula. What's A? -1. What's B? What's C? All right, what's the quadratic formula? All right, so quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So the x-intercepts are going to equal. What's the opposite of b? 8. Plus or minus the square root of b. What's b? Remember, we put that in parentheses. Remember that on test 2? Minus 4 times a. What's a? Times c. All divided by 2 times -1. So I get 8. Now remember, at that point, that's where we worked with the radicand. And remember, this is also called what? The discriminant. The square root of -8 squared is 64. What's a -4 times a -1 times a -7? -28. Because a negative times a negative times a negative is a negative. All divided by -2. What is 64 minus 28? 36? So I get 8 plus or minus square root of 36 over -2. What do you remember by the square root of 36?
perfect.
36 is a perfect square, so what's the square root of 36? 6. And so since the square root no longer there, that means you're going to end up with what kind of solutions? Rational. Very good. Some of you remember some of this stuff. So I can say 8 plus 6 divided by negative 2. What's the other? Divided by negative 2. What's 8 plus 6? And what's 14 divided by negative 2? Okay. What's 8 minus 6? What's 2 divided by negative 2? So my X-intercepts equals, what are they? Negative 7, comma, negative 1. On the worksheet, you're probably going to be asked to write this as an ordered pair. So as an ordered pair, you would say negative 7, comma, 0, and then negative 1, comma, 0. All right, now remember, the discriminant is a perfect square, right? And remember on test number 2, there was a question about the discriminant. If the discriminant is a perfect square, you get how many solutions? 2, and what are they? Rational. That means that quadratic equation is factorable. So let me just show you how to factor it, just in case you wanted to do it. But what I would do, if you're not sure if it's factorable or not, then just do all of them using quadratic formula. All right, so if I go back to this quadratic equation right here, negative x squared minus 8x minus 7 equals 0. What part of this quadratic equation throws you off? The negative x squared. A. Normally when we factor something, when we did factoring, A was what kind of number? Positive. Well, could I divide both sides by negative 1 if I wanted to? Yeah. What you do one side, you do the other. So if I wanted to, I could have divided both sides by negative 1. And so when I divide all of these by negative 1, what's negative x squared divided by negative 1? What's a negative 8x divided by negative 1? What's a negative 7 divided by negative 1? Equal. What's 0 divided by negative 1? And then this, you can see that this is factorable. X times x is what? X squared. There's only one possibility. What two numbers multiplied together is 7? 7 and 1. The last sign's positive. That means these signs in here have to be the same, and they're that middle sign. So that means they're both what? 7, 1. Once you got to that point, now remember on test 2, you had to do one by factoring. So once you got to that point, what was the next thing you had to show me?
Split and do each side.
What property were you using? Zero factor property. So you said each one equal to 0. If you have 2 or more factors whose product is 0, then one of them better be 0. So use zero factor property. So remember, you went from a quadratic equation to linear. So what's x over here? And what's x over here? All right, so you found your x-intercept. But they're not all factorable. So rather than spend 3 minutes trying to determine if something's factorable, then go straight to quadratic formula. All right, and then from here, you can graph. So let's go ahead and graph. Let's see. All right, so I can use the smaller graph paper. All right, so let's graph g of x. So my vertex is negative 4, 9. Negative 4, 9 is in the second quadrant. Negative 4, 9 over here. My axis of symmetry. Draw your axis of symmetry. Or a dotted line. Dash. My y-intercept's negative 7 right here. My x-intercepts are negative 7 and negative 1, right? So negative 7. Now let's suppose when you use quadratic formula, you got something like negative 7, and then you said, well, my other y-intercept, my other x-intercept's here. Can that be? No. They have to. Those intercepts have to be symmetrical about the axis of symmetry. They have to have that same distance. So if you say put one here and then put one here, and then all of a sudden you do this and turn that in, and I'm like, what in the world are you doing? Because that didn't even look like a parabola. So it's -7, -1. I've had people do that, by the way. They'll do this, and all of a sudden they'll do something like this. Is that a parabola? Then don't. You know you did something wrong. Erase it and then figure it out. All right. So then, oh, by the way, over here, if I know this y-intercept's on the graph, then what are the points going to be on the graph?
One on the opposite side.
Yeah. What's this distance? How many units? 4. So 1, 2, 3, 4. So here's the other. All right. And then remember that etch a sketch. Just do the best you can. All right, and then this side. Just make it look like a curve. All right. Okay, so, I mean, this little part could have been a little bit better, but it is what it is. Okay? All right. Now let's do one more with a quadratic function that's in general form. Okay, let's look at this one. Oh, and remember, we can always go back and answer those other questions as well, the range and all that. Okay, h of x equals 3x squared plus 6x plus 1. 3x squared plus 6x plus 1. What form is this?
General.
It's general form. What kind of function is this? Quadratic. Now, remember, on the worksheet, it's going to ask you, is this function polynomial, exponential, logarithmic, or rational? Well, first of all, you know it's not exponential, because if it's exponential, where should the variable be located? In the exponent. All right. You know it's not logarithmic because there's no logs in that equation. You don't see the word log. Last semester you did some stuff with rational functions. A rational function is where the variable is also located where? In the denominator. What are those denominators here? 3x squared divided by what? 1. 6x divided by 1. 1 divided by 1. So did I mention any variables in that denominator? This would be rational. So remember that from last semester? You may have forgotten, but one of the things you did, you multiplied rational expressions together, you divided, you added them. Remember you had to find the LCD and all that? So you had all that. So that's a rational function, because where is the variable located? In the denominator. All right, so you have a polynomial. Remember we talked about rational expressions last semester. That's where you had a polynomial divided by a polynomial. Okay, so which one is it? Polynomial. All quadratic functions are polynomials. So it's this one. Okay, so how do I find the vertex? Vertex formula. Negative b over 2a for the x coordinate, and then since this is h, it will be h of negative b over 2a. All right, so what's a over here? Yeah, you shouldn't mess that one up because they're all what? Yeah, but they're all positive, right? B is 6 and C is 1. Okay, so the x-coordinate of the vertex, -6 divided by 2 times A, what's A? So that's -6 divided by 6, which is? -1. So my vertex has x-coordinate -1. How do I find the y-coordinate of the vertex?
Substitute -1,
So you're really finding h of what?
-1.
-1. So I get 3 times -1 squared plus 6 times -1 plus 1. Order of operations, -1 squared is? 1 times 3 is? Okay, so that's 3 right here. This is -6?
Yeah.
What's 3 and a -6? -3 plus 1?
-2.
-2. So my vertex is the point -1, -2. What's the axis of symmetry? X equal -1. So you got to say x equal. So the axis of symmetry is x equal -1. Does the parabola open up or down? It opens up. Am I going to have any x-intercepts?
Yes.
Yes. Because if you think about this in your mind, -1, -2 is in the third quadrant. Since A is positive, what's A in this case?
3.
3. Positive 3 is going to open up. So I am going to have x-intercepts. So let's find it. So to find, well, first of all, let's find the y-intercept. The y-intercept's easy. What's the y-intercept here?
1.
1. You let x be 0. It's your constant. When x is 0, we're going to find a y-intercept. You let x equal 0. 3 times 0 squared is 0. 6 times 0 is 0. What's left? 1. All right, so far I have this. I have the vertex -1, -2. I have the axis of symmetry. I have the y-intercept +1 right here. So if I know this one, then I know another point right here, correct? The idea of symmetry. 1 unit to the right, 1 unit to the left. All right, and then let's find the x-intercepts. Now, before I go on, where are those x-intercepts going to be located? Look at the points that you have so far. Where if I find them, where will they be located on the x-axis?
Somewhere higher than -2 and somewhere lower than
So on the x-axis between -2 and what? 0. Okay, good. Because you know it has to do something like this, right? All right. So let's find the x-intercepts. You let y equal 0. So I'm going to take this quadratic function. I'm going to set it equal to 0. 3x squared plus 6x plus 1 equal 0. All right, what's A?
3.
B?
6.
And C.
1.
So let's use the quadratic formula. So the x-coordinates will equal, what's the opposite of B?
-6.
Plus or minus the square root of 6 squared minus 4 times A, what's A?
3.
Times C,
1.
all divided by 2 times A, 2 times 3. Then we dealt with the radicand, the discriminant. What's 6 squared?
36.
So I get -6 plus or minus the square root of 36. What's the -4 times 3 times 1? -12. All divided by 6. So I get -6 plus or minus the square root of 24 divided by 6. All right, now, the difference between this and the one on test 2 is this. The one in test 2, specifically you were told to solve this quadratic equation. And also, if you can simplify the radical, you simplify the radical. Remember that? So what perfect square did you use on test 2? 4. 4 times 6. But since I'm graphing, don't do all of that. You're just going to estimate what those x-intercepts are. So leave it as it is. So knows the difference between the types of questions. So in test 2, you were specifically just told, solve this equation. And nowhere in those directions did I say estimate on test 2. But I did say simplify the radical, if possible. But here, don't do that. Just use your calculator. First of all, split it up, though. Now, before I go on, just see if you kind of remember some stuff. Is my solutions, are my x-intercepts going to be rational or irrational? Irrational, because the 24 is not a perfect square, so you still have the square root of 24. So my x-intercept is going to be negative 6 plus the square root of 24 divided by 6, and then negative 6 minus the square root of 24 divided by 6. All right, so here's how you use your calculator. You see that numerator? What's in that numerator? What's in the numerator? You just told me part of it. What's in the numerator? Negative 6 plus the square root of 24. This whole thing has to be divided by what? 6. So on your calculator, you're going to say negative 6 plus the square root of 24. Then press what? Well, okay, close parentheses. Then press what? Enter equal. And then, see, that's the numerator right here. Then divide by 6.
We're going to the 10th.
Yes, so negative 0.2. Okay, so my x-intercepts is approximately equal to a negative 2/10. Over here, negative 6 minus the square root of 24. That's your numerator. Do that first. So negative 6 minus the square root of 24, close the parentheses, press equal. That's your numerator. Then I got to take that and divide by what? 6. And so oops.
Negative 1.8.
Yeah, so negative 6 minus the square root of 24, close, press equal, then divide by 6 equal negative 1.8. And then we say that the x-intercepts had to be somewhere between negative 2 and 0. All right, so negative 0.2 is about here. That's one of them. And then negative 1.8 is about here. All right, and then just do the best you can with graphing this, and you're done. All right. Since if I had any erase, I would erase this a little bit better, make it more like a curve, because it looks like a straight line right here. But I don't have any eraser. All right. Okay. All right. So that takes care of part 4. Tomorrow we do one more problem with quadratic functions. That's in general form. We're going to use the quadratic formula again.